Hello.
How are you doing?
Wow, what a car, man. Nice paint job.
Let's go for a drive and have a chat.
Yeah, sounds good.
Yeah, I don't think I've driven a car over 600 horsepower before. That's the first time. And for something this big and this heavy to go from 0 to 60 in 2.5 seconds
It's quite a bit, yeah.
It's amazing, actually.
It's a rocket ship.
Yep. Yep.
In a BMW like this, for example, the biggest, the heart of this is the engine,
yes.
right? The big piece here is like that this is actually designed and engineered by BMW themselves. It's actually one of the parts that they are building and also like obviously very proud of, and it's like that's what makes this car this car. And I think what we are seeing now is like in electric vehicles, this is actually getting more and more so. So it's not just the engine, right? It's like more parts of the puzzle are getting integrated.
Right.
And that ultimately comes down to like things like computer vision and compute and all of these things. And I mean, this is like, I think there's a parallel to Yellowbrick as well, right? Where like, it's the more you integrate and the more you build by yourself, the more performance you get out of it.
There's some really good analogies, and I mean, I think when we went ahead and built our data warehouse, just like there have been massive advances in engine technology, power, electrical. I mean, the platforms that our computer applications run on, right, which means your CPUs, your storage devices, your network devices, your memories, all of these things move forward at 1,000,000 miles an hour as well. And when there's a really profound shift in one of those technologies, it means you need to rebuild the powertrain, not just change the engine. And I think that you saw some parallels in the storage world here earlier, where what happened was when this new type of media called flash came along, people took out the hard drives in the thing and put in the flash drives and kept the rest of the system the same. And it didn't really work very well. Yeah. So it's like if you take this out and put in an electric motor from a bunch of lawnmowers or something, your car will move. It will be a moving car, but you're not leveraging electricity, right? So we've seen this time and time again now. The first big evolution with Yellowbrick was this flash memory stuff, and restructuring the database, how data's laid out, how data's indexed, how it's found, even how the data is processed, because you have bandwidth from storage that's just as fast as memory, so you don't really need to use memory for a lot of processing anymore. You don't do caching or any of that stuff. That was sort of thing number one, but now, this year the next thing is you've got 64 cores in a CPU. Probably next year you'll have 96 or 128 cores in a CPU, which means you can have 200 CPU cores per server. How do you leverage that? You don't just take traditional multi-threaded software and go run hundreds of threads on the thing. It runs terribly. So making software scale to that level requires a bunch of re-engineering as well and sort of re-platforming of that software. You can't use Linux to do that stuff. And the third area, I guess, would be, just advances in hardware, data processing, networking, data movement, all of these things as well. Whenever these new hardware trends come along, it brings an opportunity for you to change the rest of the system in a new way. And that's what we do at Yellowbrick. And just like you're talking about the car, we look at that holistically as part of one balanced machine, which is your data warehouse. How do you get, and everyone loves performance, right? But the most performance, the most users, the most bang for your buck, the smoothest experience out of the thing. And every time a new enabling hardware technology comes along, it changes that equation, and you have to make structural shifts in the software stack. Yeah, which is why you've got to own the whole software stack and the whole thing. Just like in BMW, you own, as you're saying, the engine, the vehicle, and everything else. And that way you engineer the thing for purpose, and it does a damn good job. Really complex stuff, right? Yeah. And the brilliant, as we look to what the cloud has done in databases, is it's all about friction removal in that world.
Yeah, and I think, we are also seeing a world now where like these traditional lines between on-premise and cloud, like sort of transition away, right? Like you have all of a sudden you have data in this database over here, and you have that data in that database over here. And you still need to have both at the same time and both talking to each other. Yeah, and I think that's a real shift that we're seeing.
Yeah, exactly. And everyone wants the cloud user experience regardless of where they are now, because cloud at the end of the day means how do I put this in park there? No, it's in reverse. I think
you need to.
Let's just turn it off. Yes. Good point. Yeah, good move. So I think that people now, everyone wants the cloud user experience regardless of where they are. Easy to use, easy to provision, easy to get data in and out of, 100% web-based interfaces, no installation of any crap. And I think, as we look at our opportunity, a big part of that is to bring both the cloud user experience to on-premises customers as well, and people running in the network edge in their own data centers, which also means elasticity, instant provisioning, all of this sort of stuff, so that for people who build data centers, run data centers, use colo, run hybrid projects, they can get all the benefits of that cloud database for themselves wherever it is. But at the same time, there's also a advantage of bringing parts of the on-premises user experience to the cloud. And that might seem contrary initially, but so much legacy enterprise integration exists in large enterprises. So much legacy enterprise on-premises integration exists. Like ETL, for example. In some cases, literally, we will find customers where ETL was set up 10, 15, 20 years ago from certain systems, and people have forgotten the passwords. The software's out of support. They don't want to change it and meddle it. We have one hospitality customer where part of the ETL involves someone going every week to a machine to take data out of the machine, load it onto thumb drives, walk it over, put it, then load it into the database. It couldn't be done manually.
Sounds amazing.
It's the Internet of Things without connectivity. That thing had no network connectivity at the end of the day. It was a purpose-built machine, but it wasn't on the network, so you physically had to plug something in to move your data. And all of these are cases where integrations into 10, 20, 30-year-old systems, there's a lot of mainframes out there still that people use. It's great business. Being able to move those integrations easily into the cloud because you're compatible and can exist in that world as well is, on the surface a contrarian benefit, but actually makes a ton of sense of people looking to migrate to the cloud.
Yeah.
So kind of our whole focus there, I guess we covered some areas, but it's around real engineering of an end-to-end system to get jobs done well, changing powertrain software stacks, everything as new capabilities in those underlying systems come along. We do that brilliantly, but also this notion of taking the cloud user experience to on-prem and the on-prem compatibility out into the cloud as well. And I think that's why what we do is really special.
Yeah,
no one else has that.
And it's super efficient.
And very fast.
And super small.
Yeah, and very fast. And very fast. Yes, and yellow, just like this vehicle. And it screams. It's really fast. And I think there's a lot of table stakes when you buy data warehouses, but once you're through the table stakes, which is it reliable? Does it replicate? Does it work in the cloud as well as on premises? Is it compatible with the stuff that I have? Is it easy to use? You get past those table stakes, everyone wants more speed.
Yeah, fair enough.
So it's more users, more data, more analytics, more throughput, less restrictions, more queries. You want everyone in your company that wants to have ambition to do things with data to be able to do it. And obviously you need to be able to, from a security perspective, make sure they can only access the stuff they're allowed to. But everyone should have the ability to query and use that data and do stuff with it. All of that means more speed. And if you use one of these purely consumption-based billing things, your cost works against you because you don't want everybody going and running giant queries because your bill just escalates, right?
Yeah. No, I mean, actually, I think it's a very good segue at BMW. I mean, this was pretty awesome. We saw 150x improvement and still much cheaper, like at a fraction of the cost of what it was before. And that's ultimately what it is, right? Like more performance at less of the cost, fraction of the cost.
Yeah, and I think we certainly hope at BMW that once we've, old warehouse migrated, running in production really smoothly, the next thing will be, let's just open up this data to more and more people to gain more insights and explore more and benefit the business further. So.
Yeah, sounds great.
All right.
Shall we?
Yes, let's swizzle. It's a nice view up here, actually.
Oh yeah, very nice. So I was told about this, about
sport.
Yeah, the track mode, but I'm not gonna do that. That's what they warned me about.
It's like they said, don't do that.
Yeah, don't do that.
Yeah, exactly. Okay.
Yeah, so I mean, I think one thing that our guys one thing that I think is generally interesting for customers is how do they get the data into your system, right?
Yes.
Because it's not something that it's that common, which for all the reasons that we talked about earlier, right? Which is it's completely integrated. That's why it has this tremendous performance boost, which people want. But then you have to migrate the data into the system. So maybe you can explain a little bit how that piece worked.
Yeah, there's a lot of different ways of doing that, and it really depends on what your world looks like today. So if you're, for example, one of the much more modern technology programming shops, you probably use tools like, you're to your left, sorry.
Okay.
Go out. It's very agile. If you're one of the more modern technology shops, you want to use tools like Kafka and Spark for moving data.
Mm-hmm.
Yellowbrick's a real-time data warehouse, which is really cool. So you can take Kafka feeds, stick them. Kafka's a message queue. It's basically taking events and routing them to different systems in real time. So you can take any events that are happening in your business, feed them into Kafka, have Kafka spool it out into Yellowbrick, and you can do it in real time. So that literally someone presses a badge, opens a door, an event happens, someone checks into a hotel, right there and then that data is in the data warehouse and waiting to be analyzed. So that's really cool.
Yeah, can you maybe explain this a little bit more to me? Like, so the thing is, like, what I've learned is there are like basically different systems of data warehouses, right? So there's like usually you have a real-time system which like does transactional data, and then you have like data systems which is basically like your data dump with all the legacy stuff in it.
Yeah, so the answer is it's really complicated in terms of the situations customers find themselves in. In the really simple sort of old school world, you have transactional databases which are OLTP systems that do your sales and your ERP and your CRM, and they typically move data once a day into a data warehouse. The data warehouse is where you take all of those databases and pull the data together from across them and analyze and report on it. In the more modern world, things have got a lot more complex because a bunch of stuff is now real time. You don't only want to get answers on yesterday's data. So that's where technologies like Kafka came along. Because they let you take events that are happening in transaction databases, events that are happening in devices around the company, events that are happening on video cameras, anything that can generate event data, and stream that into a variety of target systems. And yes, the challenge is traditionally people would have to have one target system for dealing with the real-time data, which is typically some in-memory thing that can only hold a small amount of data, and then one system for dealing with the older stuff, which can hold more data and has higher capacity and higher throughput. And the reason is because the storage and analytics technology that you use for old data requires, tons of brute force and storage layout to optimize for compressing data and everything. But that's all a very expensive process when you're writing data into the system. So, when you're in a real-time system, typically you can't afford to recompress all of your data every time a new event comes in to optimize for that. So,
and I mean, for maybe just like for the real world, like if you do, let's say you're a bank and you really want to do like fraud detection, like whether somebody is like using your credit card and whether he's supposed to or if he isn't. So how does that work if you have like, let's say this old like legacy system and then you have a transactional database? How do they do that? Like
with difficulty, I think. We actually have one customer that provides exactly that service, and they'd struggled for a long time with the competing demands of how do I get the transactions into the analytics system as close to real time as possible, combined with, hey, just a few months of data is hundreds of terabytes here. I need to compress this data really, really well. And I need, hundreds or thousands of concurrent users looking at this at the same time. Because all the different banks, card issuers, merchants all have things that they're investigating and looking through. So Yellowbrick's the first time they were really able to do that. And we do that because we've sort of designed our data storage and analytics technology to be able to store data in a form that's optimal for real-time data, but also for long-term data, and unify that view of those two data stores. So it's like a real-time system and a analytics system all built into
all in one. And what is the business value of that for your customer? Like what do they get out of it?
So it depends really how important real time is for the business. So a lot of the old insurers, for example, don't really care so much. I mean, there's only so many things that happen in insurance every day and you can afford to wait a bit. But if you're in the market of risk and analytics, the faster you can rerun your model on new data that's come into the system, the faster you can catch new crooks at the end of the day. The quicker you can react to new patterns, because the models that you're using is more up to date, and then if someone wants to manually inspect, the data's sitting right there in the same system as well. So for people in the risk business, the more recent the data and the faster you can analyze that literally is money.
So one thing that obviously I think is probably on a lot of people's minds is like they've seen the Snowflake IPO, and I think that brought a lot of attention to like data warehouses in general. So can you maybe explain to me like how do you compare, what's like the difference? And I mean, we talked a lot about performance today, so
absolutely.
Would love to understand how that is.
It's a really exciting business. Snowflake's IPO couldn't be better for everyone in the data warehousing space, because it shows that the values that can be gained by sort of unlocking more business value in data. it's a really big deal. I think that when we look at this market, what's interesting is Snowflake is still a tiny player. This is a market that's valued, 20 billion a year, 12% CAGR, something of that order. And, most of your players are Microsoft, Oracle, IBM, Teradata.
Yeah, and still most of it is on premises,
yeah,
right?
Exactly. Mostly on premises. Still 85% on premises spend today is the best industry analyst estimate right now, with the cloud side growing much faster. But nice 12% CAGR in the market. So I think what's exciting for us is we have an incredibly fast data warehouse. And one of the things in the data warehousing industry is you can't actually publish benchmarks of your competitors directly.
Yeah.
But what I can say is we've had customers of many cloud-based, cloud-only databases with Yellowbrick running Bakeoffs, and it's not uncommon to see 25 times the price performance from Yellowbrick for these highly interactive, ad hoc discovery type workloads, where you need quick answers to quick questions really fast by lots of people at the same time. Our model works so incredibly well for that that translates into either up to a giant cost saving or a giant performance increase for more users.
Got it. So what's the sort of like the data volume where it really starts making sense?
Terabytes.
Okay.
Yep, as long as you're in the terabytes, you're fine.
Okay.
Tens of terabytes better. And when you get to petabytes, I don't think any of the cloud-only warehouses will handle that efficiently, with perhaps the exception of BigQuery, but again, at massive cost. Whereas with Yellowbrick, with petabytes of data in your warehouse, you can slam that interactively, you can have giant background queries going on at the same time, and you can do that economically. It's just not possible to do that with most databases that are cloud-only today.
Got it. Yeah, so I mean, this car accelerates like from 0 to 60 in 2.5 seconds.
It's crazy.
And like, if you look at the data warehouse, one thing that was very, very funny to me personally, when like the BMW colleagues looked at the first, basically the first data they got back when they ran like the data warehouse in Yellowbrick, was like, it was all zeros. And they were like, what is that? Well, something's wrong, something's broken. And then they realized the scale was wrong. The response data was there. It was just like so tiny that they actually had to adjust the scale to like see how fast it was.
That happens sometimes. People go and run the query like, what, it must have made a mistake. It can't be the right answer. And nope, that's the right answer, and it came back really, really fast. But in some cases, you get some suspicion because you just never expect a database to answer your questions that quickly.
That fast, yeah. And how does it scale? Like, if you put like more volume into it, is it just gonna, is it gonna be similarly fast, as fast, or is it gonna slow down?
No,
how does it work?
It scales really well. And I mean, the key thing is you've got more data and more volumes. Queries that look at all of the data will take longer.
Yes.
That's just the law of the laws of nature and software. But not all queries look at all data. So often, even though you put more data into your warehouse, a number of users will look at what's happening right now, what happened in the last month, or let me try and think of this idea and correlate this thing. And that stuff runs just as fast no matter how much data you have in the warehouse.
Got it. So can I, as a customer, just run my normal BI applications on top of this, or do I need to change something?
No, and that's, remember we talked a little bit about earlier about the benefit of the cloud user experience on-prem as well as the on-prem experience in the cloud.
Yeah.
And the great thing is whatever BI you have, ETL you have, data movement tools, data mining tools will just work with Yellowbrick. Whether that's, Informatica Power Center, SAS, Tableau, R, Python, and a whole bunch of modern tools. All of it just works with Yellowbrick, yeah.
Wow, that's awesome. And how do you work like with other cloud providers like AWS and Azure?
They're all our partners at the end of the day. So we're a software as a service company. So if you use any of the cloud providers, they have technology called Private Link that lets you basically connect to any SaaS service and use that in your VPC on the same logical network. Data is secured, the stuff's on your network, stuff never flows over the internet or unencrypted networks. And actually, even if you're in AWS, that's the best way to consume a lot of their services as well, through Private Link. So to use Yellowbrick, you just use Private Link in your cloud provider and you're off.
Got it. Yeah, one thing that for us in terms of like an investment, from an investment perspective, was like absolutely mind-blowing is obviously the speed and the performance ratio to like cost. And what that really meant for us is like, we think in the future there will be only more data. It's like people will want more insight faster. So it's really all about getting that to them. So one thing that we thought was pretty awesome is that you're able to deliver this kind of mind-blowing speed, and therefore basically allowing the future to grow in terms of data volume.
It's about more data as well as bringing data sources together as you get more data. I don't know if there'd be an analogy in the car world, but a lot of the more modern vehicles collect so much data now when you're driving them, right? The number of
it's like petabytes a day,
especially as you move towards self-driving, right?
Yeah.
So that petabytes of data, you're going to need analytic systems at the network edge in order to work out what's good, what isn't good, what do I want to keep, because you can't keep petabytes every day for every car forever. It's just no point, right?
Yeah.
But then when you get that data, you've got all your existing data sources within BMW, whether it's manufacturing data or finance data or buyer data or other things, that you're going to want to correlate some of that stuff.
Yeah, fair enough. Otherwise, you don't have any insight.
Exactly, and insurance companies will want to do that as well, and you'll want to say, well, hey, based on how people are driving and data and telemetry I've got from this car, when do I think it's due for maintenance? When was the last maintenance record? At some point perhaps, how safe is the driver driving this car? Like the telematics type use cases. All of that requires not just more data, but bringing together more and more disparate data sets as well. And that you've got to have a fast database, a strong data warehouse to do that. Oh, did someone just pass us, Kasper?
Yeah.
We got passed by a Porsche. That's an old one. That's embarrassing. I thought you were supposed to be the racing driver here.
Yeah, I didn't want to get us killed.
This isn't exactly Top Gear. Yes.